Hello friends, we are going to start with one of the finest chapters in maths. Okay, it's a difficult chapter, let's put it that way. And the name of the chapter is called Similarity. The weightage of the chapter, usually 2 questions are expected in board exam. 2 questions, 6 to 7 marks. Yeah, 7 marks is what I expect or assume. Right, so let's attack this chapter. Now what exactly do you mean by similarity? Check. In similarity, okay, the triangles are not same. They are not congruent, they are similar. So if I'm talking about similarity, I wouldn't say the triangles are same. I'm extremely sorry. Check this out. If I'm drawing 2 triangles, let's say one triangle is a big triangle and another is a very small triangle. Now obviously these 2 triangles are not same, they are not congruent. Let's name the triangle as A, B and C. And the other triangle, name it as P, Q and R. Okay, if I say, just for instance, yeah, if I talk about the sides, I say this is 6 centimeter and this is 2 centimeter. Yeah, just assume, yeah. Let's say this is 12 centimeter, this is 4 centimeter. And let's talk about this to be 21 centimeter. It's not 21 obviously, but just a random example I'm taking. 21 centimeter and this is 7 centimeter. Now tell me, these are the 3 sides. It's just an example I'm giving you all. These are the 3 sides of a triangle. Now tell me the ratios. I would love it if you tell me the ratios. Tell me the ratio of AB upon PQ. Can I say AB is 6 and PQ is 2? That means my answer on cancellation, the ratio is 3:1, 3 upon 1, right? Sounds good. That means AB ka size is 3 times PQ ka size. Can I say it's called a scaling factor? Scaling factor means it is 3 times larger than PQ. On a similar note, if I'm talking about BC is 2QR, BC is 12 and QR is 4. Obviously on cancellation again you get the answer the same, 3:1. And if you're talking about AC to PR, ratio of AC to PR, it's going to be 21 upon 7. Again on cancellation the ratio 3:1. So can I say the 2 triangles are not same, sorry, but their sides, the ratio of their sides are in proportion. The ratio of the sides are in proportion because they all are in the ratio 3:1. So can I come to a conclusion that AB upon PQ ka ratio is same as BC upon QR ka ratio, which is same as AC upon PR ka ratio. Therefore the 3 sides are in proportion and I can say that these 2 triangles are similar. This is the symbol of similarity. So I can say triangle ABC obviously is similar to triangle PQR, and the reason is SSS test of similarity. We call it as side and side test because the 3 sides are not equal. They are not equal. The ratio of the sides are in proportion. So yaad rakhna, kindly remember that in similarity the sides are never going to be equal. Yeah, they can be, but usually we don't have any sum where the sides are equal. The sides are in proportion. The ratio of the sides are equal. Ratio is equal, the sides are not equal. Kindly remember that, right? So this is one concept which you have to drill this in your brains, that the triangles are not same, they are similar. Okay, this is one of the tests in similarity which we encounter, and the name of the test is side test, where sides are not equal, they are in proportion, ratio is in proportion. The second test, now just imagine that this side is not given, the 12 wala side is not given. Okay, I'm not giving this side, I'm sorry, this is not given, but instead of that I give you an angle. For instance, between the two of them, angle B, let's take for instance, is 60 degree and angle Q is also 60 degrees. So now can I say that the third portion has changed? This has changed, and instead I can say that angle B is equals to angle Q and it is equals to 60 degrees. That means two sides are in proportion. These sides are in proportion and the angle between the two sides is equal. The angles are equal, but the sides are in proportion. The ratio of the sides are in proportion. So I can say by side angle side test, yeah, because two sides are in proportion, the ratios are in proportion, and I can say that the angles are equal, the angle between the two sides. So the name of the second test in similarity is side angle side test. So we have 3 tests overall, out of which 2 tests I have already written. Now say for instance, let's come to another set. If I say another 2 triangles, okay, another set of 2 triangles, let's say this is one triangle and this is another triangle. So you have again ABC in the show and you have PQR. If I say that this angle is 60 degrees and this angle is 70 degrees and this is also 60 and this is also 70. So now tell me one thing, can I say the two angles are equal? Angle A is equals to angle P, which is 60, and this is given, angle B is equals to angle Q is equals to 70. Enough. Two angles are equal, you don't have to prove the third angle, because it is common sense कि अगर दो angles equal है तो by angle sum property this has to be 50 and this has to be 50. Common sense. So can I come to a conclusion that in order to prove similarity, the third and the most important test is angle test. So I can say that ABC, triangle ABC is similar to triangle PQR, and the reason is angle test of similarity. And please remember one thing, that you don't have to prove the third angle at all. Okay, in our syllabus 95% of sums are based on angle test. Around 4% of sums are based on SAS test and only 1% is based on SSS test. So basically I want you to remember one thing, that the most important test in the history of mankind in similarity is angle test. Okay, now one thing remember, after you prove the triangles are similar, एक बार तुमने prove कर दिया कि triangles are similar, उसके बाद after that you have to write a statement which I am writing here. So if you get this, that the triangle ABC is similar to triangle PQR, then instantly, without giving a thought, without looking at the sum, without knowing what knowledge to have in a question, you write down this step. It comes complementary. Once you are proved, एक बार तुमने similar proof कर दिया, फिर ये step लिखना है. कौन सा step? Check it out. I'll show it to you which one. After this, the step to be written is this: AB upon PQ, first 2 upon first 2. Namings are very important in this chapter. Is equals to BC upon QR, which is equals to AC upon PR. And the reason for this is corresponding sides of similar triangles are in proportion. Okay, I also call it as, I also call it as CSSTP. Now what do you mean by CSSTP? CSSTP means C for corresponding, S for sides, Another is for similar triangles are in proportion. Corresponding sides CSS of similar triangles are in proportion. In board exam, shortcut is not allowed. Never. You have to write the full statement only. But as of now, when I'll be solving the sums, I'm not writing this entire statement over and over again. Because every sum after you prove the triangle similar, this step comes muft, like free. You have to write it. Or after you write this step, then we will see what the question is. I personally call it as katha. चल ना, मैंने बनाया है, क्या प्रॉब्लम है तेरे को? कथा का मतलब क्या? That without katha, without taking God's name, there is no success in life, there is no peace in life, there is no stimulus in life. Okay, katha means it is compulsory, you have to write it. I don't want to listen to any excuses of your, oh sir, I forgot, sir, silly mistake. No, you are silly. You have to write, after similar, you have to write this step. And the name of the step, the reason for the step is CSSTP, shortcut is not allowed. Right? So I would love that you would first go through the 3 types of tests. There are only 3 tests in similarity. Congruency had 5 tests. Similarity made the first test with SSS test, where sides are in proportion, they are not equal. Second test is SAS test. And the most important test is angle test. Okay, that's it. So all the sums are based on one of these 3 tests, right? So let's start with the first sum from the textbook. Okay, the sum I have already mentioned out here, right? So check out on the question. In the board exam, diagram is compulsory. You have to draw the diagram in the answer sheet. Fine. Let's start. Since the diagram is already out here, look, I am not looking at even the question. मैं sum देख ही नहीं रहा हूँ. Okay, fine, I'm not cheating. My intention to tell you this is that don't read the question, just look at the diagram. Once you see the diagram, your first intention towards the sum is prove the 2 triangles similar. Forget the sum, it's a request. First step towards success is prove the 2 triangles similar. Acha, now I call something as namkaran. Namkaran means you have to name the triangles very cautiously. You can't name any triangle anything whatever you like. No. So let's name them. So solution mein, first in triangle, check it out. APC. I went this way. APC. So the first triangle I can write it fatafat. In triangle APC and triangle A के सामने कौन है? Like Clash of Clans. Who is against A? A के सामने कौन है? B. So can I say it is going to be BPD? So if you are taking A, सामने आएगा B. So APC, it will be BPD. They are going opposites. That's how you have to name. And namkaran, naming is very important. Varna all your sums will fall ill. They will go erroneous, wrong, ganda, incorrect, dirty. Naming is very important. APC, I hope you understood na. A के सामने B है, तो BPD. Naming is utmost important. Okay, can I first say that, listen, these are vertically opposite angles. You must have heard about vertically opposite right from 7th standard. So the first point is angle APC. Okay, I'm sorry, I just goofed it up. Yeah, angle APC is equal to angle BPD dot. The reason is vertically opposite angles, board exam mein shortcut is not allowed. I'm again telling you, I'm tired. Second, have you heard about Z formation? Yeah, Z formation means interior alternate angles. Exactly, you have. Now that can be only done when the lines are parallel. So can I say these lines are parallel? Check the arrows. So if the lines are parallel, oh yeah, can I say this angle should be equal to this angle? That is ACP. Okay, angle ACP is equals to, check this out here, please, check ACP from the naming. ACP, look at the flow, ACP, then the flow should go this way only, BDP. Are you getting? If it's ACP from the diagram also, it is going to be BDP, where D is going to be the angle of concern, right? So namings is very important. You get the namings right from here only. So is equals to angle BDP. And the reason is interior alternate angles. So guys, I have proved my two angles are equal. No need for the third angle. So I can say therefore triangle APC is similar to triangle BPD. And the reason is angle test of similarity. Acha, after this, the step which I have requested you all is this AP upon BP, the katha. AP upon BP is equals to PC upon PD is equals to AC upon BD, sorry. And the reason is katha. Katha matlab CSSTP. Every statement has a reason, right? And after this, now I read the sum. Okay, now I read the sum. Okay. First, you prove that the triangles are similar. So we are done with that. So the first part has been accomplished very successfully. Okay. Now they have given the values. All you have to do is substitute the values. Come on. The first value BD is 2.4. Please substitute. Where is BD? Here it is. I am making a dot. 2.4. Then AC is 3.6. Okay, 3.6. This is upon. Then PD is 4. Where is PD? Here it is. Look, I am making dots. 4. PC you have to find out. And last PB is 3.2. PB here 3.2. AP you have to find out. Okay, so fifth statement. And what is the reason of this statement? That is, it is obtained from 4, and I can also say it is given because the values have been given and the reason of substitution is statement number 4. So now all you do is just cross multiply. So your statement number 6 is going to appear like this. Cross multiply, please. PC, the 4 goes out there. Cross multiply. So PC is equals to 4 into 3.6. I can write 36, remove the decimal, and 24, remove the decimal. Fine. I think you have understood that, right? So out here, check it out. The cancellations. 12 2s are 12 3s are, and 2 1s are 2 2s are. So can I say it is 6 centimeter is PC, the length of PC. And now if I am talking about AP, cross multiply. So AP is 3.2 into 3.6 upon 2.4. Okay, so I'll just write it out here. AP is gonna be 3.2 into 3.6, the whole upon 2.4. 12 2s are 12 3s are, and 2 1.6 are. So the answer of AP, yep, comes out to be 1.6 into 3, 4.8 centimeters. That's it. So this is the end of the first sum. So all you have to do is, guys, just prove the two triangles similar, write katha, substitute, finish. Okay. Coming to the next question. Check out on this sum. Okay, a question is already there. We'll have to make a diagram. Okay, now according to the question, I have been told in a trapezium ABCD. So I think first we need to draw a trapezium. Okay, let's draw a trapezium ABCD where AB is parallel to DC. So a simple trapezium follows this way. I'm sorry about the figures and the drawings out here. It's difficult. Okay, so this is A, B, C and D, where I have been told that these two lines are parallel to each other. Fine. The next part of the sum is the diagonals meet each other at point P. Now if I join this and if I join this, okay, the diagonals are intersecting at point P. That's what they have said. Now can I come to a conclusion that if the lines are parallel, I can see a Z formation, interior alternate angles and vertically opposite angles. See now, oh friends, these two are equal, and with a Z formation, this and this, come on, Z formation, right, are equal. Ho gaya. So let's start with the namkaran. Okay, the namkaran is at utmost important. I'm time and again I'm telling you that. Okay, so in triangle DPC, in triangle DPC and triangle D के सामने कौन है बता? Who is opposite D? It is B, the clash of clans. So DPC BPA, Bappa. This, it goes this way. Oh my god, there's gonna be a hit and run case. So it's gonna be DPC BPA. That's how the name should be, opposites. वरना पूरा कथा रॉन्ग चला जाएगा. Okay, so first things first. Can I say angle DPC is equal to angle BPA? The reason is vertically opposite angles. Oh come on my friends. Second, angle, the Z formation, dude, the Z formation, how can you forget it? Angle DCP, in this chapter there is going to be a lot of Z formations and all. So mind you, you remember this, is equal to angle BAP. The reason is interior alternate angles. Interior alternate angles. So हो गया ना. So can I say by angle test, triangle DPC is similar to triangle BAPA, and the reason is AA test of similarity. And after this, free muft katha कौन लिखेगा katha? If you don't write katha na, you just see, I'll not talk to you. The first two is DP upon either first two is BP. Next PC, the next two, upon PA, the next two. DC upon BA. Are you understanding na yaar? Okay. And the reason is corresponding sides of similar triangles are in proportion. Shortcut not allowed. Now check. I am ready with my setup. I call this as a setup. Similarity mein, if you notice na, 80% of the times I will not even read the sum. Oh no, I don't want the sum. I'll just read the data, the given. I'll draw, I'll prove them similar. I'll write katha and I'll be ready with my setup. If you do that much, trust me, 80% of the game is over. And now I'm gonna first time see the sum. Right? So in this question, I drew the diagram. Oh, I proved them similar. Now check the requirements. PA into PD. Okay, PA into PD. Let's search. Hunt for PA. Oh yeah, PA is out here. And PD is out here. Oh, wonderful. And then I want PB and PC. There. PB, BP same hi hota hai. And PC. Excellent. So I have everything with me. Okay, so all I do is, I don't need this. Hey, don't do all these things in exam. I don't need this. Just cross multiply both of them. So fifth step, can I say PA into PD? PA into DP. DP is as good as PD only, na? Come on, yaar. Yeah, just cross multiplication is equal to PC into PB. PB into PC. And the reason is statement number 4 only, you just cross multiplied it. Hence proved. So this was the solution to the sum which is given out there. Okay. Let's proceed with the next question, guys. Okay, check out on this sum. in a quadrilateral ABCD. So let's start drawing a quadrilateral ABCD. Quadrilateral is a four-sided figure. ऐसा कोई जरूरी नहीं है कि वो ट्रपेजियम और स्क्वायर ही होना चाहिए. It is just a random four-sided figure. Yeah. ABCD, A, B, C and D. And best part is that the lines are not parallel. No, you can't assume. In maths, you can't assume anything. I'm sorry. So one thing is for sure, that the lines are not parallel. DC and AB, in the previous sum, it was given parallel. Arey yaar. In the previous sum, check na, AB is parallel to DC was given. But in this, it's no mention of the word parallel. Okay, I have been told that these diagonals intersect at point O. So this one and this one, they intersect at point O. Sounds okay? And also I have been told AO is 2 times CO. I'll just write the given out here. I need it. So given is AO is 2 times CO. Get the CO down. Get it down. Can I say AO upon CO? The ratio is 2:1. And similarly, BO is 2DO. BO is 2 times DO. Get the DO down. Therefore, BO upon DO is also 2/1. Now, can I say the two ratios are equal? Come on, the ratios are in proportion. This is 2:1 and even this is 2:1. So, can I say AO upon CO is equal to BO upon DO? Lovely. And third thing, what is this? Come on, what is this? Yeah, hey friends, what is this? These are vertically opposite angles. Vertically opposite means you don't need parallelism concept. So I can start this way. Let's begin the show, guys. नामकरण very important. In triangle DOC, D के सामने A नहीं है. I'll punch you in the face. DOC के सामने है BOA, BOA. So in triangle DOC and triangle BOA, first angle DOC is equals to angle BOA. Reason is vertically opposite angles. Shortcut not allowed. Second here it's given. This is equal to this. They both are equal. 2:1 ratio. So can I say AO upon BO? Isn't it equal to? Oh, my bad. It is AO upon CO. AO upon CO is equals to BO upon DO, and both the ratios are 2:1. Can I say given? So if they are equal, can I say two sides are in proportion? The two sides are in proportion and the angle between the two sides is equal. So by SAS test, I can say that triangle DOC is similar to triangle BOA. The reason is SAS test of similarity. Acha, after the test, what do we write? Katha. If you forget this, I'll cancel your admission. Fourth, DO, check out. The first two is DO and out here it's BO. So DO upon BO is equals to OC upon OA is equals to DC upon BA. And the reason for this is CSSTP. Okay, now check what you need. What do you want? You need OA and OD. Where is OA? Just find out. No, just find out na. Where is OA? Here, OA and OD. Then you want OB and OC. OC and OB. Lovely. All you do is just cross multiply. So you get OA into OD is equals to OB into OC. Statement number 4. Hence proved. So basically I don't see the question only. I just prove जितने भी triangles दिख रहे, try to prove them similar and just write katha. 80% you have won the game. Okay, let's go ahead with one more question and then you can take a small break and we'll come back together. Right, let's do one more question, please, guys. Now, this is a solution. I'll just write it down. Check. The next one. Alright, fine. Again, a diagram is given. I'll just utilize the diagram. Very simple sum. Very simple. Namkaran in triangle DOQ. DOQ. D के सामने कौन है? B. So it's gonna be BOP. DOQ BOP. Fine. First, can I say एक तो वापस again the same old stories, vertically opposite angles. So angle DOQ is equals to angle BOP dot 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 vertically opposite angles. Second reason, the lines are given parallel. Students, if the lines are parallel, can I use the Z formation? So angle DQO, if I see DQO, this one should be equal to P. इधर देख, it goes this way. DQO, wouldn't it be BPO? BPO, right? The reason is interior alternate angles. हो गया, therefore the two angles are equal and therefore I can say triangle DOQ is similar to triangle BOP. The reason is angle test. Write katha. DO BO OQ OP DQ DP. CSSTP. Now look at the question. Question में BO is given as 6 and DQ is given as 8. Okay. So check this out. BO. Where is BO? Here. Hold on. Okay. BO is given as 6. DQ is given. Where is DQ? Here. You have to find DO into BP. Yeah, this is BP. Well, basically all you do is just cross multiply. You don't need this at all, the center ratio. Cross multiply. DO into BP is equals to DQ into BO. Right? So statement number 4. So DO into BP, DQ is given as 8 and BO is given as 6. So your answer is going to be 8 6 are 48 and this is your statement number 4. So this is the solution of the question. Fine. So all of you will just go through these sums. We'll go with the next set of questions after this. Alright guys, proceeding with the next sum. I am not even looking at the data. I'm just looking at the diagram. So I just want to tell you, inform you that first step is prove the triangle similar. Forget everything else. Okay. So first things first. Just one moment. Okay. Select the two triangles. One of the selection of the triangles is GHD, in which I can see H is 90. Okay. So one is GHD. I'll quickly write it. In triangle GHD and triangle, let's see the other triangle. Now you only tell me the other triangle would be this one, right? in which F is 90. That is EFD. But the naming has to be very appropriate. Listen, the naming has to be very precise. H is 90, no? Where is H located? H is located at the center. So with H, which is 90 degrees, who is 90 in the red triangle? F. So can I say F should come correspondingly in between at the center. So एक तो है H is 90 और उसके साथ F is 90. At the center they are located. Namkaran has to go in hand, synchronization. Now can I also think about, there is something called as common angle D. D is present in the green also and D is present in the red also. The complete angle D. कहाँ पे है D? देख इधर देख. Isn't D situated at the last? End में आता है. तो इधर भी D किधर आना चाहिए? End में. So the naming should be EFD. So the naming has to be very precise, I am telling you. अच्छा, एक बार naming हो गया खत्म ना, you have already proved. Haven't you said that H is 90 and F is 90? So angle GHD, isn't it equal to angle EFD? Because they both are 90 degrees and the reason is given, right? Second, D is a common angle which is present in green also and the red triangle also. So angle GDH, isn't it equal to angle EDF? The reason is common angle. Common angle. And therefore, can I say therefore by angle test, triangle GHD is similar to triangle EFD. The reason is angle test of similarity. And then you write Katha, which is very much obvious. So GH upon EF is equals to HD upon FD is equals to GD upon ED. The reason is CSSTP. All you do is substitute. Now check. I have been told DH is 8. Where is DH? Where is DH? Here, 8. DF is 12. Where is DF? Here. DG is given and ED is given. But basically you have to neglect this and substitute the rest which are obtainable. So the fifth step, HD is 8 upon 12 is equals to 3x minus 1 upon DE is 4x plus 2. The reason is that's not the reason. The reason is given. Yeah, it's given, right? These values are given and from statement number 4. So I will say statement number 4 and the values are given. Now all you do is just cross multiply. 4 2s are 4 3s are and cross multiply. So 2 times 4x plus 2, isn't it equals to 3 times 3x minus 1. Open the bracket, you get 8x plus 4 is equals to 9x minus 3. Continuing out here, 9x minus 8x is equals to 4 plus 3. So you get the answer of x as 7. So the value of x is 7 and you have to find the lengths of DG and DE. Okay, DG, isn't it 3x minus 1? So DG is going to be 3 into 7 minus 1, 21 minus 1, that is 20 centimeter, right? And DE is 4x plus 2. I'm writing out here. DE 4 into x, which is 7 plus 2, that is 30 centimeter. So these are my respective answers of DG and DE, right? So I'll just box the answers which I have obtained One of them DE is 30 and DG is 20, right? So simple sum again. This is the solution. Coming to the next question. All right, now this is a difficult sum. Yeah, this is a classy sum. It's one of the finest sums in the textbook. Okay, in this question, ABCD is a rhombus. This is given. Rhombus means all sides are equal. So can I start this way, that since ABCD is a rhombus, we can clearly mention that all the sides are equal. So AB is equals to BC is equals to CD is equals to AD. All sides are equal. In a rhombus. Short में. Acha, now what exactly do you have to prove in this question? You need to prove, beg your pardon, 1 second, dp into cr, dp into cr is equals to dc into pr. Fine. This is TPT. Fine, this is what you have to prove, right? Okay, let's begin with the show. Wonderful question. Now check it out. What all things are given? What all things are given or observable? Listen, DP means I am interested in this part. Fine. CR means this entire. Okay. DC is this part and PR is this part. So now the most important thing is, what should be the naming of such a triangle? Which triangles will you prove similar? ऐसा triangle select करो जिसमें majority of the sides are covered. I will select this triangle, that is DPA, and उसके सामने I'll be selecting this triangle. Okay, so again, if I just neatly draw everything on what exactly is needed, my selection of the two triangles shall be this. One of the triangle is gonna be DPA and another triangle is gonna be this. So in triangle DPA and triangle, in opposite of D is your RPC. Okay, first thing, it's very common sense that it's vertically opposite angles. So angle DPA is equals to angle RPC, and the reason is vertically opposite angles. The second is the Z formation, because it's a rhombus. Now all of you all, we should know that in a rhombus all sides are equal and even the opposite sides are parallel. So it becomes a which formation, my friends? It becomes a Z formation. Yeah, this and this. So I can say angle ADP ADP is equals to angle, look at it, it's ADP. So out here also it's gonna be CRP. And the reason is interior alternate angles. And now can I say, therefore by angle test, triangle DPA is similar to triangle RPC, and the reason is angle test. And after this you can straight away mention the Katha. DP upon RP is equals to PA upon PC is equals to DA upon RC. Corresponding sides of similar triangles are in proportion. Now look at the requirement. I want DP, here this one, then I want CR, this one, I want DC, I don't have, and I want PR. Everything is there except DC. So what I'm planning is I'm gonna just remove this for the moment. I want this, I want this, I want this. I don't want DA. Let's cross multiply first. DP into CR is equal to PR into DA. Statement number 4. Now check, it's a rhombus. Do you know in a rhombus all sides are equal? DP I obtained, CR I obtained, PR I obtained. I am in hunt for DC. Now tell me again, I am saying that instead of DA, next step, can you write DA is equals to DC because it's a side of rhombus. All sides of rhombus are equal. So can't you mention the next step, instead of DA you can write DC, and hence proved. Yes. So this was the solution for the sum. Okay, coming to the next question. Okay, one more wonderful question, a very difficult sum. It's a huge sum. Now, isme I have been told that there is a triangle PQR. Okay, in triangle PQR, Q is 90 degrees. Let this be Q. It's 90. P and R is the hypotenuse. PR is the hypotenuse. QM is perpendicular to PR. So this is also perpendicular. So there are two 90 degrees. One is this and one is at the bottom. Okay, so this is how the diagram figures out to be. Okay, talking about this as 90 and talking about this as 90. My first step in any sum and similarity is जितने भी triangles similar है ना, prove it. I can personally see 3 sets of triangles are similar. 3. One is left side wala small triangle PMQ and the entire triangle PQR is similar. I can prove it. Wait, no. Second is the right side of the triangle and the entire triangle PQR. And the third set is that these two small triangles are similar. So I am going to prove 3 sets of triangles similar. How much? 3. So let's begin the show. In triangle PQR, let's name the big triangle instantly. In triangle PQR and triangle, the left one small पे जाते, focus on the left side wala small triangle. Now you only help me out, please help. In this big triangle, who is 90? Q. Q is 90. In the small left triangle, who is 90? M is 90. तो जहां पे Q है उधर बीच में M आना चाहिए. Once more, in this small triangle and the big triangle, can I say P is common angle shared by both of them? The complete angle P comes in PQR also and PQM also. So P is a common angle. If P is starting में लिखा है तो इधर भी P ही आना चाहिए. So it should be PMQ. Proof is already done. Angle PQR is equal to angle PMQ because they both are 90 degrees given. Second, angle QPR is equal to angle MPQ. The reason is common angle. So therefore, can I say that the triangles PQR is similar to triangle PMQ, and the reason is by again angle test of similarity. Fine, and there you go, finish. And there you can write the katha, right? PQ upon PM is QR upon QM is PR upon PM. CSSTP. Perfect, guys, right? So out here, let's write down the reasons. Few reasons have not yet been mentioned by me. This was given. This was common angle. This was angle test and CSSTP. Perfect. Now look at the first one. PQ square. PQ square, PQ square, PQ square. Oh, it's there, not there. 1 second, students, I have made a mistake. I suspect it should be PR upon PQ, the last one, not PM. Here I made a mistake. It should be PQ. So I want this and I want this. You can neglect it. Cross multiply. So the fifth statement, PQ into PQ, you cross multiply. You get PQ square, PM into PR. Statement number 4. So I am done with the first part. Now for the second part, what I'm going to do is I'll be drawing the diagram once more. Okay, then only I'll be able to explain it more thoroughly. So let's come along with me. At the bottom of the page, I'll be drawing the diagram again, a small short diagram. Okay, same diagram. This is 90, this is 90, proper, and out here we have P, Q, R, M. Let's take this triangle and the full triangle. So first quickly naming the full triangle again. In triangle PQR, tell me one thing, who is 90? Q is 90. राइट साइड के ट्राइंगल में हु इज 90? राइट साइड M is 90. M. तो where Q is situated, M should have the same strategic location. अच्छा, PQR में and this triangle में can I say we have a common angle R which is completely present in both PQR and QMR. So R is at the end, so R should be at the end. It's going to be QMR. Again, the first step is angle PQR is equal to angle QMR, which is equals to 90 given. I'm not writing the reasons now. Second, angle QRP, and either it is going to be MRQ. The reason is common angle R. Okay, therefore I can say by angle test, triangle PQR is also similar to triangle QMR. And therefore by the katha, PQ upon QM is QR upon MR, PR upon QR. Did you get this? And all you have to prove is check. You have to prove QR square. Can you see QR, QR, QR? Yes, I can see them. Here and here is PM into MR. You don't need this. Cross multiply. So QR square is equals to PR into MR. Statement number 4. That's it. This is the second part of the question. So first I proved the left triangle and the complete triangle similar. Then the right triangle and the complete triangle similar. And now I'm going to prove the two small triangles similar. इसके लिए I call it as a T method sum. कौन सा sum? T method sum. Okay, there is going to be some part of geometry which I'll be using. Listen, the first thing, let me call this as X. This is 90. Okay, so this angle is going to be 90 minus X. I can prove it. Let this be A. Angle sum property. A plus X plus 90 is equals to 180. So X is equals to 180 minus 90 minus a. So can I say x is equals to 90 minus a, right? So a is equals to 90 minus x. Fine. So this a part I obtained as 90 minus x, but this complete angle, let me call this as b. It's geometry. We know a plus b is 90. अरे you can see ना, a left side का है और b right side का है, दोनों मिलाकर 90 है. Substitute a का value out here. 90 minus x plus b is equals to 90. 90 cancel. Minus x plus b is equals to 0. Can I say b is equals to x? Oh wow! I have proved that the two angles are equal. Which two angles have I proved? Check. You have proved this angle is x and this angle is also x. So in the two small triangles, you will not be able to prove. अरे ये दो triangles को similar proof करने के लिए you will have to use the geometry method. Else it's not possible to prove them similar. So by geometry, I have proved that the two small triangles are, these angles are equal. This angle and this angle. By geometry I have proved it. अच्छा, अभी इसका नामकरण कैसे लेने का? In triangle PMQ, and it should be triangle QMR. I call it as a T-shaped sum. PMQ QMR. PMQ QMR. Yeah. PMQ. Yeah. QMR. That's how you do it. T. Twing, twing, twing. Twing, twing, twing. Ta-da. Twing, twing, twing. Twing, twing, twing. Du-dun. That's called T-shape. You can't change the naming. You have to go with this same naming. Can I say एक चीज तो है, they both are 90, right? So first step, angle PMQ is equals to angle QMR because they both are 90 degrees. That's the first thing. And the second thing is, I just proved that P is X and udhar Q is X. So MPQ इधर आएगा MQR. You can check Q ही बीच में आता है. So angle MPQ is equal to angle MQR. They both are X, and the reason is by geometry. And therefore I can say, oh yes, the triangles, the two small triangles, that is PMQ, is similar to triangle QMR, and the reason for both of them is again angle test. Katha you write by yourself, you get the third part also. So guys, it's a big sum in which you have to prove the left side and the complete similar, the right side and the complete similar, and the two small triangles similar. Right? Alright, wonderful question. Fine. Okay, before this question I want you to just revise the sums which I have solved. I have solved 9 sums. We are going to take approximately 25 to 30 sums, which I'm going to do it with you all in similarity, covering every concept.